Okay, so today you're going to learn about double angle formula. Okay, so let's prove how to get a double angle formula. So as you know, sine A plus B, right? So it is sine A cos B, right? And then plus sine B cos A, all right? So if we change the B or A into A or B, that means we have sine A plus A. So sine A plus A, you can see here becomes sine A cos A plus sine A cos A. So B become A lah, and then cos B become cos A. So you get a 2 sine A cos A. So therefore, is sine 2A is equivalent to 2 sine A cos A, right? So this one, this formula is we get it from sine A plus B lah, from additional formula. So cos 2A, so cos 2A is actually is cos A plus B. So you have cos A cos B, right? And then you minus sine A sine B. So if you change the B become A, okay, so it become cos 2A lah, because A plus A 2A. Then you'll get cos A, then sine A, sine A. Okay, cos A times cos A is cos square A, right? And then sine A times sine A is sine square A, right? Sine square A. So cos 2A, we have this cos A, cos square A minus sine square A. So if we change sine square A into 1 minus using the identity. So identity is cos square plus sine square equals to 1, right? So if we change the sine square become 1 minus cos square. So you have cos square A minus 1 minus cos square A. So you get cos square A minus 1 plus cos square A, right? So eventually you get cos square 2 cos square A minus 1. And same goes to cos 2A, right? If we change, okay, cos 2A, initially is cos square A minus sine square A, right? So we change the cos square A become 1 minus sine square A. So minus sine square A. Okay, so you get 1 minus 2 sine square A. So this is the other formula for cos 2A. Cos 2A, there is 3. So 1, 2, 3. Then tangent 2A. So it's 2 tangent A. How to get? All right, so same thing, same tangent A plus tangent A. It become tangent A plus tangent A, right? Then 1 minus tangent A times tangent A. So equivalent to 2 tangent A over 1 minus tangent square A. So this is the formula for double angle for tangent, right? So this one you have to memorize. So memorize is better. So there are 5 formula here. Okay, now example 16. Okay, find the value of each of the following using double angle. Double formula is not additional formula. Double angle formula. Double angle. formula, then check your answer. So 2 sine 15 cos 15. So it's 2 sine A cos A, right? So this one is wrong, huh? So it's 2 sine A cos A. All right. So 2 sine A cos A is sine 2A. Therefore, we can write this one as sine 2 times 15. So it's sine 30 degree. So sine 30 degree is 1 over 2. Okay. Next, tangent 112.5 over 1 minus tangent square 112.5 is same as 2 tangent A over 1 minus tangent square A. So it's equivalent to tangent 2 times 112.5. So you get tangent 225. Okay, tangent 225 is same as positive tangent 45 degrees. Therefore, is 1. Okay, then 1 minus 2 sine square 75. So this one we are applying to this one, this formula. So it's equivalent to cos 2a, right? So cos 2a, so I use green, cos 2 times 75 degree. So you get cos 150 degree. So cos 150 is negative cos 30 degree, because in quadrant number 2. So this is a reference angle in quadrant number 1. So quadrant number 2, cos is negative, therefore negative cos the reference angle. So you get negative square root 3 over 2. Then lastly, 2 cos. So I use blue color. So it's same as this one, cos 2a, right? So I use blue. Okay, so become cos 2 times 150. So it's cos 300. So cos 300 in quadrant number 4. So cos is positive, cos, and then 300, the reference angle is 60. Okay, how to get 60? Still remember? You ask yourself how to get 60. Yeah? How to get reference angle is 60, right? So this one, cos 60 is 1 over 2. So this is your answer. So this is example 16 by using double angle. So now prove the identities. Okay, prove the identities. Okay, given the cosec 2a is 1 over sec a over 1 over cosec a. So we prove from left to right. Left to right. Cosecant 2a is actually 1 over sine 2a. So 1 over sine 2a is 1 over 2 sine a cos a. So we take this, separate into 3. 1 over 2 times 1 over sine a times 1 over cos a. Therefore, you get 1 over 2. 1 over sine a is secant a. Then 1 over 1 over sine a is cosecant, right? All right, sorry. This is cosecant a. 1 over cos is secant a. So you can rewrite this as 1 over 2 secant a times cosecant a. So this is right hand side, right? Correct. Okay, now we go to B. Okay, B. Right. So we prove from right to left now. Right to left. So is you have cos 2b over cos b plus sine b. So what is cos 2b here? Right, cos 2b. So it's either 2 cos square b minus sine square b, or 2 cos square b minus 1, or 1 minus 2 sine square b. Okay, so either one of these, right? So if you choose the wrong one, and I mean you choose the if let's say you choose first one, second, third, you still can get the answer, So here I choose cos square b minus sine square b, okay, over cos b plus sine b. So how to continue? So this one I will factorize right into two column, right? Two column. Okay, so I'm using this property, x squared minus y squared equals to x minus y times x plus y. Okay, so I'm using this property. So we have cos b plus cos, okay, plus sine b, then cos b minus sine b, right, over cos b plus sine b. So you can see here, I simplify, I simplify, so I will get the answer cos b minus sine b. So this is left hand side. Okay. So maybe I can write properly. Here is cos. Okay, then C. Okay, C, we can prove from left to right. What is cos 2p? And then cot p, okay? Cos 2p is, all right, so you can choose 2 cosecant p minus 1. Then your times cotangent is cos p over sine p, okay? So you can see here, right? So I want the answer cosecant. So that's 1 over sine. This one also sine. So meaning that I cannot use this. Okay. So I have to change into 1 minus 2 sine square p, right? Times cos p over sine p. Okay. So when you multiply, okay, you get 1 over sine p, then minus, okay, 2 sine square p cos p over sine p, okay? Right, so this one, okay, this one, if you use the new, okay, this one, there's a mistake here, right? This one should be cotangent p, right? Okay, cotangent p minus sine 2p. So here, you can see cos p, so you get cos p, yeah, cos p over sine p, and then 2 sine square p times cos p over sine p. So sine p, sine square p and sine p, we cancel out 1, and then you will get this one is cotangent p minus 2 sine p cos p. 2 sine p cos p is 2 sine a cos a. So you get sine 2a. So here is sine 2p, right? So this is your answer. This is on the right hand side. So please do the correction here. Then next is 1 plus cos 2x equals to sine 2x cot x. Okay, so here we start from right side. So therefore is sine 2x cot x. So is 2 sine x cot x, cos x. Okay, cos x, and then cotangent x is cotangent x. I use a bracket to differentiate. There are two terms there. So here is cos x over sine x, cos x. Yeah, cannot write properly. So here is cos x over sine x. So you can cancel out sine and sine. Okay. Right. So you will get 2 cos square x. Okay. So 2 cos square x is actually if you use a double angle, is cos 2x equals to 2 cos square x minus 1. So 2 cos square x is 1 plus cos 2x. So it's 1 plus cos 2x. So it's left hand side. So correct. Right. So this is example 17, proof. And then example 18, find the value. So let's see. Sine A is 4 over 5 and A is between 0 and this is 90 degree. So this is A is an acute angle, right? So acute angle. So let's say this is A. Okay. So therefore, sine A is 4 over 5. So opposite over hypotenuse. Okay. Sine is so. Okay. Still remember this. So ka tua. Okay. So ka tua. So SOH, opposite hypotenuse. Therefore, this is 3 lah, using Pythagoras theorem. So you have a cos A is 3 over 5 and tangent A is 4 over 3. Then we have another B. B is tangent B is 5 over 12. So tangent B is positive. So positive tangent is should be in quadrant 1 and quadrant 3 still. And then B is between 180 and 360. Therefore, B is in quadrant number 3. So quadrant number 3. So if I draw this, so here is B. B. So B is what? Tangent B is 5 over 12. So 5 over 12. So 5 here. Opposite over adjacent. So this one automatically this is 13 now, right? And then you know that in quadrant number 3, all right, quadrant number 3, this one negative 12 and negative 5, right? So because if you draw the diagram, is here. So here the coordinate, if you use a unit circle, so the coordinate here is actually negative 5, negative 12, right? For A. So therefore, what is, if tangent A is 5 over 12, then sine A is negative 5 over 13, right? Because this is Pythagoras theorem. Then cos A is negative 12 over 13. Yeah. All right. Okay, now we can solve this. Okay, by the way, this one you change this one cos 2A, sec 2B, tangent 2A, and then this one is cotangent to B, right? So what is sine 2A? Sine 2A, okay, you can use 1 minus 2 sine square A using double angle. So 1 minus 2 times 4 over 5, then you square. So 1 minus 2 times 16 over 25. So you have 32. So 25 minus 32. So you have 25 minus 32. So you have negative 17 over 25. Okay. How about cosecant 2b? Cosecant 2b is 1 over sine 2b. So on the sine 2b is 1 over 2 sine b times cos b. So what is sine b? So sine b is sorry, this is b. So this is b and b. This is b. Sine b is negative 5 over 13. And cos b is negative 12 over 13. So if you use calculator, you should be able to get 169 divided by 120, 2 times 5, negative 10 and negative 12. So whatever in numerator, you become denominator, right? So tangent to A will be 2 tangent A over 1 minus tangent square A. So what is tangent A? So tangent A is 4 over 3, right? And then 1 minus 4 over 3 square. So you use your calculator again, right? So you should be able to get the the answer negative 24 over 7. Okay. And then the last one is cot 2b. Cot 2b is 1 over tangent 2b. So this one is the ballet with this. So let's mean 1 minus tangent square b over 2 tangent b. So what is tangent b? So it's 5. So 1 minus 5 over 12 square over 2 times 5 over 12. So you use your calculator, you should be able to get the answer here. Okay, so do it by yourself. So this video is about double angle, how to prove, how to solve if given the ratio, and also how to solve complicated, not complicated, meaning something to do with the double angle. Then you can find the value of special angle using double angle. Okay, so this is the video for double angle.